Hi everyone, welcome to the very first tutorial of our Superior Agent Summer Residency program. Over the next couple of minutes, you will get a tour of the AI agents landscape, hopefully enough to take you from an absolute beginner to an excited innovator. By the end, you will understand core concepts like autonomy versus automation, simple agent architectures, and learning paradigms. We hope that this foundation will set you to build up and launch your own Superior agents for our summer residency program, where you can win prizes for demonstrating real-world survival and evolution in your agents. Without further ado, let's dive in. First, let's construct automation with autonomy. Automation follows fixed rules. Think a basic email filter that flags anything with free money. Autonomy goes even further than this. It builds and updates an internal model of its environment, refines its logic, and makes decisions not explicitly programmed. So you can imagine an email agent that learns from marking of your spam over time, adapting to its patterns of its own. That's autonomy. It's crucial for agents that must survive and evolve in dynamic, real-world settings without a human babysitter. Now let's consider how agents are built with simple agent architectures. First is reactive agents. They're super fast. They map inputs directly to outputs, but they can't plan ahead. It's direct stimulus with direct action, but no memories involved. Next is deliberative agents. They build an internal world, a model plan, can be slower. So it's model-based planning with internal worldview. The sweet spot is hybrid agents, which layer a quick reactive components with a deeper learning module. This lets agents respond instantly to new events and deliberately on strategy, much like you might instantly dodge falling objects and decide where to move for safety. So overall, hybrid agents combine reactive speed with deliberative depth. Next, I'd like to talk a little bit about learning paradigms as well. To give agents intelligence, there's various different learning paradigms that are applied. Supervised learning requires labeled data. So this is almost like feeding a model thousands of cats and dog images, and unsupervised learning finds hidden patterns in raw data, clustering similar images without labels. Self-supervised learning blends both of these together. So it has teaching models to predict the parts of the data from other parts. Understanding these paradigms will really help you to choose how an agent and understand acquires knowledge, whether if it's classifying content, finding clusters, or bootstrapping from raw inputs as well. So overall, supervised learning learns from label examples, cats versus dogs. Unsupervised learning discovers patterns in unlabeled data. Self and semi-supervised learning, mix of both, leverages structure in data. Now, I'd like to talk a little bit about deep reinforcement learning and its basics. So I will give an example in here that I'd like you to understand. Reinforcement learning is central to many autonomous agents. And reinforcement learning agent lives in an environment. It observes a state, acts, receives the rewards, and moves to a new state. Its objective? It's to maximize total rewards over time. Key challenge is the exploration and exploitation trade-off. Should the agent try something new, explore, or repeat a known winning action, exploit? Reinforcement learning gives agents a framework for self-improvement through trial and error, very much like evolution, making a powerful tool adaptive behaviors. So if you were to look essentially at an interaction loop, agent observes a state S, takes action A, gets reward R, and reaches a new state S. The goal, again, to maximize cumulative reward over time. And I would say that the explore versus exploits, the balance trying to new actions versus using the good ones, is a very ongoing literature that's been in this ecosystem. The next one is why autonomy matters. So why do we actually even care about autonomy? And I'm assuming you will ask this to yourself because we will be mentioning this throughout the program over and over. Well, first, scalability. The truly autonomous agents actually reduce the need for constant human oversight. The second, robustness. Autonomous agents can handle unexpected events. Even if they encounter something new, they can adapt instead of failing. So the third point comes the continuous improvement. Using evolutionary loops or self-learning mechanisms, agents can self-correct and get smarter with each interaction. In essence, autonomy is key to move from narrow systems to resilient, self-optimizing AI. Now let's talk about evolution of AI. Let's zoom out for a bit and see how we actually got here. In the early days of NLP, many of the humans relied on rigid rules, basic stats, and afterwards the deep learning era introduced transformers, the models that understood context at scale. And to many of our lives, consumers, and even to developers, ChatGPT and LLMs brought conversational AI into the mainstream, enabling natural dialogues with minimal prompting. So now we're actually entering the AI agent phase. We're talking about chaining large language model calls, hooking agents to memory stores, planners, and external tools. This progression moved us from static text generation to dynamic, goal-driven systems. Now I believe it's a time to introduce superior agents, our evolutionary AI architecture and framework. It's inspired by Darwinian intelligence, and as it helps agents to be evaluated on survival metrics, persistence, replication, and utility. And agents are not just judged by human ratings as well. It's like I mentioned, it's all by survival metrics. The cycle has essentially 4 steps. Initialization, where agents boot with initial settings. You can pick your own foundational model. Self-evaluation using ungameable success criteria. Replication, where strong agents spawn offspring to save critical data. And continuous adaptation, where real-world feedback drives evolution. We believe that this loop truly creates a self-improving AI that thrives in dynamic environments. So again, to wrap up, we looked briefly at the AI agent landscape, from simple automation scripts to autonomous evolving agents. We believe that we gave you some of the high-level architectures, learning paradigms, and why autonomy matters. So now we hope that you can take this information and explore this area a little bit more. And within the next couple of sessions, we will be diving into multi-agent orchestration a lot more in detail to understand how to compose a team of agents. And later on, we will be also looking into model context protocol basics on how to connect agents to real-world data and series. So we hope that with all of these skills that you combine, you will be ready to launch your own Spirit Agents use case and compete for prizes at the end of our program. Once again, thank you for your attention. You can scan this QR code to access to our docs, and you can find our Notion guides and Discord channel as well with all of the resources that you have. Don't hesitate to any of the questions in our Discord or during our office hours that we will be hosting. The goal is to make this summer residency program as engaging as possible for all of you and give you a chance to learn about this landscape in just about 4 weeks' time. Thank you.